So this is lesson on completing the square and complex solution. Sorry, this one. Let's do the 16 first. Uh, Solving quadratics. Let's solve quadratic equations. So what are we? Our student target is I can solve quadratic equation by completing the square method or by using quadratic formulas. I'm gonna go straight away to the student task, that is solve quadratics. In 16.1, you can see find the perfect squares. One example is already given to you. Let me make it bigger. Okay, so the expression here, this is x. There is a quadratic expression. This is called quadratic. I just want you to understand that piece. This is called quadratic expression. There is no equal sign. If there was a equal sign, you may say quadratic function or quadratic equation. This is just an expression. Now this is the way it is written is equivalent to form this one, x plus 4. The whole square is because you may say why? Because this x plus 4 can be written as x plus 4 multiplying itself. So you just multiply this to itself. And then you can see you can use the distributive property to multiply the x times x, which will give you x squared. Then you multiply x times 4, which gives you 4x. And then after that, we multiply, see, the inner one. These are called inner ones. That is the, again, you get 4 times x is 4x. And the same 4 is again multiplied to the 4, which gives you 16. So this is so easy. It's not difficult. Just wanted to show that. And you combine the like term, these two pieces. The first piece is x squared, but the second and the third piece, we can combine it to write it as 4x plus 4x is 8x, and the last is 16. Now look at this. You started with x plus 4, the whole square, and ended with this whole equation. And what do you notice here? What are we supposed to observe here is something nice happening is there is nice relation which works with this 4 that you see. Or the number 16 is related to 4 because it is just the square of the 4. So the number 4 is square, and that's why I get 16. There is also a relation between this 4 and this 8. And you can see it is just a double. What you do is you just multiply 2 times the 4. That's it. So whatever that 4 is, you multiply, you double it. So this is called, you double it, and here you square it. So how do we know that these two are expressions are equivalent is, there is also another, this is called three terms called, and it is also called perfect trinomial. So this is another vocabulary word used called trinomial because there are three parts, 1, 2, and 3. And perfect because we can write it as square of, so this is the square of that. And that's why two equivalent form, one is called square form, other one is quadratic, but square form. And this is the factored form also. This is also called factored form because it can be, it is, there are two factors, you don't, here there are two factors. It's x plus 4, x plus 4 is repeated. So there's a lot of mathematics here. Mm, Basically, what on the, if you try to graph this x-axis and the y-axis and the grid, and you can see this one x plus 4, this x plus 4, if you want to put it equal to 0, the only way this happens, this works out is if you plug in x equals -4, so this -4 and +4 end up, if you do like this, it is 0. It's going to be 0. And also you learned earlier classes that anything square is it is a parabolic, so it is of the form square function. So a lot of things are coming here. Let me clean this clearly and do it one more time. Watch this. So this piece that you see, actually, it is the, I can remind you of a square function, which is just a x square. So, but this is the square function, which is a parabolic, which is the graph is like this. This is the graph of that. But what does, so it goes through 0, 0. But what does this x plus 4, the new one, let's see, let's see y1. Another one, y2 is x plus 4 the whole square is. This is a new graph, which is uh, because of the plus sign, we can write it minus of minus 4. It means the graph moves at minus 4. See how beautiful it is to understand this piece. Okay, so this is the parabolic form shifted 4 places to the right. See this graph? So there is a relation between these two. So the square function which is shifted. Now you may say this plus 16 is where the graph crosses the, if I do this parabolic shape like this, it's where the graph crosses the 16, the y-intercept. So that's the y-intercept. So the standard form clearly helps how to find the y-intercept. This is the y-intercept where the graph crosses the x-axis. Then there is that plus x square means this is positive, means the parabolic shape is opens up. It means it is upward parabola. So it goes up, opens up. But if it is something like negative x square, then you see the parabolic shape is downward. So there's a lot of mathematics. Thing is, uh, so there is a 25. Now we cannot write this. It's not possible to write this. Of course, we can write it as a x plus some number. What is this number square? It is possible, but it is not a perfect. Not perfect because this 25 was 5 square, so we could easily know that it is a perfect square. Now this one we cannot do, but is there a way out? We can at least think of what can we rearrange these terms? If we could rearrange these terms and write it as uh, x square plus 10x, instead of 29, I could write 25 plus 4. See, so we can rearrange, and you know this answer is from here, from the very first, it is x plus 5 the whole square and plus 4. And you see how beautiful it is. So this is the new one, which is equivalent. It's not perfect, but we can write it as in this form, and that is called vertex form. Now, what is vertex form? Many of you forgot. It is of the form y is a x minus h the whole square plus k. Now, what is this h and k basically means? This h and k is the vertex. It is the vertex. And how do you get from the equation? It is, you always do the parenthesis, the opposite of plus 5, which is minus 5. And the other one is 4. The outside is 4, so it is plus. So that's it. So what this basically means is the graph is the vertex is minus 5 like this. And 4, if this is 4, this is the point. So the parabolic shape is beautiful. Parabolic shape that you see here is, you can see like this. The parabolic shape is like this. So this point is that minus 5 comma 4. So in other words, this big, whatever that you see here, it is the original equation. Suppose let's say y is equal to the square function x square. This is the one which shifts 5 units to the left, and you can see 1, 2, 3, 4, and 5, and it goes up 1, 2, 3, and 4, and that's the point. See? And you get the parabolic shape to write. So what did you learn here is one thing is called, this is called standard form. This is called uh, factored form. So this is so many different forms there are. This is factor, this is standard, Both are quadratic, and the one that I did here is vertex form. So vertex form is where you learn also here domain and the range. Especially the range is everything graph is above this 4. The 4 is the lowest it can go to. So it is like 4 less than y less than infinity. It means 4 is the minimum also. So the 4 k is the minimum here. This k that is say is the minimum. Of course, the word then there is something called domain. Domain can mean can we plug in any x? Yeah. In this case, there is no restriction of what x value we have to restrict or not substitute. Here we can plug in anything. It's like domain is all real numbers. It's like all this is one way to write, or it is also written as minus infinity to plus infinity. And this is called interval notation to write that, or you can the way that this one I wrote, that's called set builder form. So different approach to write same thing. So one problem, but so much knowledge there. So, but the problem is how many of us want to take this knowledge, right? And you see there is an axis of symmetry like this. This is called the axis of symmetry. You see this where this graph is symmetrical about this line, which is x equals minus 5. So a lot of information there, axis of symmetry. And on the left side, you can see the graph is decreasing. Uh, this is decreasing graph. So it's like for all x's from negative infinity all the way to minus 5, the graph is going down. And then after negative 5, it goes increasing. So that's increasing and decreasing also here. So one problem, but so much information there. Let's do the third one. Now, this third equation is x squared minus 6x plus 8. Now, see again, 8 is not a perfect square, but we can always write it as 9 minus 1. The question is, why did I write this 8? We can write it as plus 9 and minus 1. So the first three things, you can clearly see 9 is a square of 3 squares. So 9 is square of 3. And the middle number 6, the negative 6 that you see, it is the a double of 3. It is 2 times the 3. So that means this piece is a perfect square. So we can write this as in the square form. You can write x and you can see this. So I made a mistake here. This should be minus 3. So it's a double of minus 3. So we put a minus 3 here and then minus 1. So again, this is the vertex form. Okay, hope that helps. I'm to write this. Okay. And now I'm not graphing this, even though you can always do that 1, 2, 3, and negative 1. So there is that parabolic shape with something like this. It goes like this, which 3n plus negative 1 because of this h and k form. So clearly see that piece there. Let's do the last one. Okay. Now, this one is straight away. We don't have to do even nothing because this x squared, the last number is a square of 3. See, this is a 3. And in between number is 2 times. So we can write it there 2 times x. So the number is 2 times 3. 2 times 3, and the x piece is as it is there, x. So that means you can clearly see this 3 is this 3 is the important number because this 9 is a square of 3, and this negative 3 is the double of course, it is a double of 3. 6 is a double of 3. The minus is the same minus. So this answer we can write directly as x minus 3 the whole square, and you're done. And this is called also completing the square also, or here it's a straight away problem. Completing the square, we will see another method to solve quadratic equation. When we have something, we will see where as and when it comes. So Elena and Hans solved the equation. So this is in different ways. Now this is the equation. What Elena said was first I add 2. So she added plus to both sides. And the question is why she thought of add. The question is why, right? Her goal is to get there is an in between the step which is missing here, which I'm going to write here. This step is so this piece will become x squared minus 6x plus 9 equals 2. So this is a missing step there. And then you see that is a perfect, this is that perfect trinomial, which can be written as the one that we worked in the earlier examples. We did already in 6.1, problem number D, I think. You see that. So this is the same thing. This part is done. So what we can find the square root both sides. So they did find the both square. What is that means is, let me write this. So you have x minus 3 square is 2. It means if you have a square is b, then a is plus minus square root b. So this is the formula. So what that means is that the parenthesis, so the x minus 3 is plus minus 2. So that's what they wrote directly here. In some textbooks, they will say, hey, just put a square root both sides. Like, this is also another way to show, but make sure you put plus and minus. What do you do next is you add 3 both sides. So adding 3, you get x. This crosses out and you get 3 plus and minus 2. So basically there are two answers here. One is with 3. I missed a square root 2 here. So one is with plus, and you can say these two solutions are not not rational because there is a radical sign there. So there is these two solutions are all called real solution, but they are also irrational solution. So this is called also completing the square. What we did is called completing the square method. So this method is called completing the square method. Okay, let's see what did other students do is, oh, okay, I already showed that, right? So there are two solutions. Then now here, Han did another way. Let's see what Han did. So again, this is already done. Another approach to show is using quadratic formula. So the equation was given to you. This was the equation. And when I write this equation, okay, we want to solve this. You want to know when is that. Basically, what is asking is what is the parabolic shape crosses the x-axis. So that's what the understanding is. What is the meaning of solution means? Where does it cross the x-axis? That's what that means. You want to know for what x is the output 0 here. So you want to know what value of x makes this equation a 0. So in this case, there is a coefficient of x squared here. The first term coefficient is 1, and that's why a is 1. B is minus 6. So this student did a good job. So B is minus 6. So what is B is the number that times X. and C is the constant. That's where the graph crosses the y-axis. So this is where. And also what she did is she plugged in those values of B here, right here. Then she plugged in A is here and C is 7. See? So clean work there. And then again the A part at the bottom, she plugged in is 1. So she get x equals, this is for, this will combine to 4 times 7 is 28. And when you take away 36 from 28, because the inside the radical, that is the radicand. So what is the meaning of radicand? Anything that is inside is E is 36 minus this, and you can clearly see you get 8 there. And that's how she wrote this. And then there are two answers here. So one with, and remember this square root of 4, what does square root of 8? We can reduce this and write it as 4 times 2. And square root of 4 is, and we can separate this. And square root of 4 is 2. So this is 2 root 2. So what's happening is x is 6 plus or minus. Instead of 8, we can replace it by, so we can replace it by 2 root 2 and then divide by 2. And you can see if you want, you can separate this, which is 6 over 2. So separate the denominator to both. Uh, and then the 2 crosses out. So 2 crosses out. And this 2 divides 6 3 times. So your final answer is x equals 3 plus minus root 2, which is the two separate answers are one with the. So why our students do not do good for the ACT score? So I'm always trying to put in your mind, guys, hey, you have to get good score. And when we don't know all this, see, it's so simple. I'm just saying quadratic formula. Everybody has to know, like this. See, just little work there, and also how the graph looks like. What does it mean? All those little things are so important. So the two answers are one with the plus sign, and the other one is the minus. Okay. So you may want to know what is this 3 plus root 2. You want to know 3. Root 2 is 1.4, which adds to 3 become 2.4 kind of thing. If you want to see the graph of this, we want to show how the grid, how does the graph look like. You can do that also. It means one of the answer 3, this 2.4 will be 1, 2, 3. Somewhere here, this is the point. That's where it crosses. You can see the 7. It crosses at 7 also on the y-axis. We need to know what is the other one. And you can see this is 3 minus root 2. It means it is 3 minus, I'll just write here, 3 minus 1.4. So that means almost like 1.6. If you subtract from 3, 1.6, so somewhere here. So the graph goes through these 2 points, something like this. It goes through this and takes a turn and goes up like this. That's how the graph of parabolic shape, even though they did not ask you, it's good to know what is the meaning of solution means. Solution basically means the zeros. Zeros basically means where does the graph crosses the x-axis. They are also called the x-intercepts here. But the zeros may be sometimes they may not even cross on the x-axis. And that's why we have next lesson of complex numbers. Let's go to the next. Okay, so you're given x square is 38, right? Basically, it is just asking us the parabolic shape like this. Where does it cross 38? So if this is, that's all it means. Now we are not going to graph this. This is too much of work. So what we'll do is we'll use square root method, put plus and minus. Because there's a square, you have to have two answers. And the 38. And you are done. Now, question is, can we reduce to the lower form? The only way you can write it is 2 times 17. And you can say none of this is a perfect square. So we can't do nothing about it. And just write two answers. One of the answer is 38, and the other answer is plus 30, square root of 30. This is how. But remember, square root of 38 actually is between, you can see, between 36. I picked 36. And the other one I can use is 49 because you know square root of 36 is 6. So this creepy number, square root of 38, is actually a real number between 6 and 7. And maybe a bit more closer to 38 is more closer to 36 than to 49. So it's maybe 6.2 or 6.3. I don't know. We can always do maths to check, or calculator will help us. So that's what that means. This part we already did in the warm-up problem number 16.1. If you see, we already done this. This is 5 squares, see? And this 5, if you double, you get 10. So we can easily write as, so this we can write square of binomial because this is a perfect trinomial. This is a perfect trinomial. We can write x minus 5, the whole square equals 0. And then now we have square. You put get away with the square by writing plus and minus square root of 0. Square root of 0 is everything reduces to 0 because square root of 0 is 0. And when you write 0, 0 does not have a sign. It means it is plus 0. 0 can be written. Both, everything is the same thing, just like putting a 0 here. See? And adding 5 both sides, you get x equals 5. It means x equals to 5 is a solution. This is a real solution. And also it is a repeated. Another way to say that the x equals 5 is a 0 with multiplicity. Those of you who forgot 2. That means there is a square, see? So there was this 2. Because of this square, we say, hey, or you can say it is x minus 5 and x minus 5. So repeated. And that's why the x equals 5 is with multiplicity 2, and the graph is at 5, something like this. So this is what it means. It touches. So this is like the graph bounces at 5. So it does not cross like this. This is not how it is. It doesn't cross. It just touches the x-axis at 5. So that was question. So question number 5 is x squared plus, again we have 39. So step number 1, so let me write this. First step, 39 is not a perfect square. So all you do is subtract 39 both sides. So this will go away. You're left with x squared 14x. Almost the same idea here. And now you know the number here is 14. And you take the 14, divide it by 2, and then square, you get 7 square, and that is 49. So both sides add 49 plus 49. So adding this will give you, so this is a perfect trinomial. Another way to write this as 2 times 7x like this, plus 7. This is not needed, but I'm just writing, and this is going to be plus 10. You can check that. Now this whole thing will be x and plus 7. The whole square is 10. Now taking square root both the side, you get x plus 7, the whole square is plus minus square root 10. When you do that, you don't have to put this square. This is not needed. And then you subtract 7 both sides. So you get x equals minus 7 plus or minus. Now we cannot get away with the square root of 10. That stays. So your two answers is one with the minus square root of 10 and the other one is with, you're done. So this is how ACT questions will be asked. Okay, now the difference between all the earlier problem and this is, you see here, there's a 3 there. Uh, so all the problem that we did, there was a 1, so it was easier. But right now there is a 3. So how do we do this? First step is check, does 3 divide 5, 11? So if this number was 6 maybe, and this number was 30, we would easily divide 3, 3, 3. But right now we don't have that option. So so we can't do nothing about it. So what other method we can think of is 3 times 11 is 33, and 33 is 1 times 33, and 33 also is 3 times 33. And you can see if you subtract this 2, because there's a minus here, if you're subtracting this 2, you never get minus 5. So we can't factorize this. So that's not possible to factor. The only option is, best bet is to use the quadratic formula. See, your first step is you figure out what is A, B, C. Look at this. So if you see this, the A is 3, the B is -5, and the C is, all you do is write the equation for quadratic formula, that is minus B plus minus B square minus 4AC. This is the formula, and plug in the value. So minus B, so this is minus B, so B is -5. And because there's already minus here, you can just write the opposite of -5, which is +5. And then square, that is -5 square, minus 4 times A. A is 3, so that goes here. And the C is -11, so that goes right here. 2 times, and the A is 3, back again A is 3. A lot of work there, 5. We need to know what is the radicand answer. So we have to do little scratch work there. So if I see the -5 that you have over there, let me write this again here. So -5 square is 25. These two negatives will give you positive. 4 times, here there's it will work here. 4 times 3 is 12. And 12 times 11, we'll do a little multiplication. 1 times 2 is 2. And you get 132. So this is 132. And if we add this 2 here, 167. So this whole thing becomes 167. Just want to make sure we got a 132. It's a 157, sorry. So this is 157 divided by 6. So the 157, this is not a perfect square. And if you see it does not get reduced, we can just write this as two answers, one with plus 157 divided by 6. And the other one is x equals 5 minus square root of 157. So this is how, okay. Let's go to directly to 17, lesson number 17.